All right, class. Well, sorry about the last video. My phone died. I should learn my lesson to make sure it's completely charged before we get started. So we are left off taking the derivative of this function right here, the square root of x squared plus y squared. So sure enough, to take that derivative, we would have to rewrite the square root as a 1/2 exponent, right? Okay, so now taking the derivative with respect to x, this being a chain rule, right, we have to take care of the outside function first. So the derivative will take care of the outside exponent first. It's going to come up front as a 1/2, and then it's going to turn into negative 1/2. Then we need to move in and take the derivative of the inside of this parentheses with respect to x. So the derivative of x squared is 2x. And the derivative of y squared is 0 because there's no x again in this term. So making this a little prettier, the 2's definitely cancel out. The x will be at the top. And then I will write the negative 1/2 exponent. I'll make it positive by throwing this at the bottom. And sure enough, if you want, you can turn into a square root back. Okay. Let's see the derivative with respect to y. So I'll do the same thing first, take care of the outside exponent. Okay, so that turns into a negative 1/2 times, move on to the inside of this parentheses and take the derivative of the inside with respect to y, and that's going to be a 2y. So same as the partial derivative before, the 2's are going to cross out, the y stays at the top, and then the x squared plus y squared to the 1/2 exponent goes on the bottom. So as I had mentioned before about the symmetry between x and y, it could certainly save you some time. Again, see how x and y are interchangeable? So if I substitute x with y and y with x, I'll get the same exact expression, yes? So as you see, their derivatives are interchangeable as well. So once I got the derivative with respect to x, to get the derivative with respect to y, it would be the same thing except for replace all the x's with y. And again, replacing the x with y here really keeps it the same. So that could definitely save a lot of time if you notice. But again, it only works for problems where x and y are interchangeable, right? They're symmetrical, we call this. So, okay, let's move on. I have a couple more examples here. These ones are taken a step further. So what do you think it means to find this derivative here? Sure enough, it means to do what? To find the derivative, the partial derivative with respect to x, yes? And then what? And then substitute. Means to find the derivative with respect to x and then substitute what? xy with 1, right? So basically evaluate it. Okay, so the same thing here, yes. Okay, so let's find the derivative with respect to x first. All right, well, here it is. Ooh, so both of these terms are a product, so they have both x and y mixed in together. So the derivative with respect to x, remember y is just the constant, it's a coefficient, so we'll keep the y times, move on and take the derivative of ln x, and that's just going to be 1 over x, plus the derivative of x is 1 times e to the y is just the coefficient, right, the constant. Okay. So now all I have to do is plug in 1 here. So it's going to be a 1 times 1 over 1 plus 1 times e to the 1. So that's a 1. Whoops, I didn't say it right. So that's a 1 plus e. Okay. All right. Let's see the derivative with respect to y. Okay. So same thing. The derivative of y is equal to 1 times its coefficient, which is ln x, plus, keep the x as a coefficient, yes, constant, times the derivative of e to the y is itself. So again, these are not interchangeable because again, substituting x with y, you'll get completely different problems. So definitely we needed to solve each problem for itself. So plugging in a 1 for each one of these, so it's 1 times ln of 1 plus 1 times e to the power of 1. Well, ln of 1 is 0, yes. So that goes away. And that's just an e. So there's your answer. All right. And one more. Here's an exponential function. Same thing. Find the partial derivatives and then substitute 1, 0 into both. Okay. So the derivative with respect to x. Okay, so first of all, any natural exponential function is going to stay the same. Times, move in and take the derivative of the exponent part. So the derivative of x squared is 2x. I believe we had that. Oh, no, we had it in a square root, but yeah, similar. And the derivative of y squared is just itself. So that's going to be 2x e to the x squared plus y squared. Okay. Can you guess what the derivative with respect to y is going to be? I'm not going to put xy. Okay, so if we use the trick from before, again, see how x and y are interchangeable? So that should come up to be 2y e to the x squared plus y squared for sure. Okay, and you're welcome to test it yourself, take the derivative, and see if you get the same thing. Now, fx of 1, 0 is plug in a 1 for x and a 0 for y, so that's a 2 times 1 times e to the 1, so that's simply 2e. Fy at 1, 0 is going to be a different story because now I have a y and not an x, so that's going to be a 2 times 0 times who cares what, because that's just going to be a 0. Okay, all right. So let's look at a couple applications. So it says, an electronics company's profit function from selling 2 products, some DVD players and some CD players, it's a daily profit function, is given below. Right here. Okay. Find the marginal profit function for the DVD players, evaluate it at 2040, and interpret your answer. So sure enough, same as before in chapter 1, when we first introduced this word, marginal is simply going to mean what? Well, the derivative, yes, of the profit function. Now, sure enough, as we just said, a function of 2 variables will have 2 partial derivatives. So sure enough, I'm asking you for both. It even says the marginal profit for the DVD players and the marginal profit for the CD players, right? Where X were the DVDs and Y were the CDs. Okay, so let's see. In other words, this is what I'm asking you for. Find PX. Oops, shouldn't say FX. It should have said PX here, because the function's called P. Okay. So the profit function's right here. Let's take the derivative with respect to x. So that's going to be 10x minus 7y, because again, that's what's multiplied to x. There's no x here, so it goes away, plus 100th, right? All right. So what is px of 2040? So plug in a 20 for x, a 40 for y, and if you're going to plug this in, it's going to be 2,000 minus 1,400. Wait a minute, 200 minus 1,400 plus 100, 300. It's going to be, wait, let me just do that. That's 200 minus, 280, right? 28 times 0 plus 100 is going to be 20. Okay. Now, could have picked better values, but let's move on. Part B says py, the derivative with respect to y. So again, there's no y in here, The derivative of this with respect to y is negative 7x. That's what y is multiplied to. Plus 6y plus 175. Yes? Okay. All right. So, taking this derivative, oh, I'm sorry, yeah, I'm just making sure. Plugging in the value, py of 2040 is going to be negative 7 times 20 plus 6 times 40 plus 175. So let's see what we're coming up with this. So that's going to be a negative 140, right, plus 240 plus 175. So that's 275. Okay. Now, the question is, what do they mean? So I saved write it all together so I don't have to double up on things. So it says they both I plugged in a 20 and a 40, yes? And interpret the answer. So just as in the previous problems, don't forget to say when this is happening. So when what? When 20 DVD players and 40 CD players have been produced and sold, what? The profit is changing, yes? The profit is increasing, so we got a positive value, by how much? Well, by $20, not much, but here it is, $20 for every what? So what did we change for the $20? We changed the number of DVD players, so it increases by $20 for every what? Extra DVD player produced and sold. So if you keep the CD players at 40, but you're gonna produce one more DVD player, so plug in 21, but keep this at 40, so for every extra DVD player produced and sold, all right, and it's gonna increase by what? By $175 for every extra CD player produced and sold. I'll just write sold. Okay, does that make sense? All right. Okay, well, here it is. So same stories, except for you're dealing now with two variables rather than just one. Okay. So I got a couple more problems for you. The first one, here's a Cobb-Douglas function. L is the number of labor units and K is the number of units of capital. And P is the production function I introduced to you last section. Okay, says find both these numbers and interpret the answer. So it's the same problem as before. So as you see here, I have a 300, L to the 1/4, K to the 1/4. Let's take the derivative. So what's the derivative with respect to L? Well, we'll keep the 300. The derivative of L to the 1/4 is 1/4, L to the negative 3/4. And just as we kept the 300, we'll keep the K. So what we want to do next is take this partial derivative and substitute in an 81 and a 625. So that's going to be 300, 81 to the negative 3/4, and 625 to the positive 3/4. So let's see, do I have that value? That's going to be, I hope, looks like to me that it's about $347.22. Okay, well, you can check that up if it's true. know. Why that? I don't know. I'll just... Oh, okay, yeah. 300, I forgot the quarter, that's why. It didn't look good to me. So 300 times a quarter, that's 75. So that's a 75. That's 1 over 27, because again, we're taking the fourth root of 81, which is 3, raise it to the third power, that's 27. So again, 1 over because of the negative exponent. So same thing here. The fourth root of 625 is 5, to the third power is 125. So plug that in. Good. Now, let's find the derivative with respect to k. So keep the 300, keep the L to the 1/4. Those are both coefficients, numbers that this k variable is multiplied to. Bring the 3/4 up front, and then decrease that exponent by 1. Okay, not gonna fix it here because anyhow we have to plug in values. So 625, so that's, well, again, 300, I'll keep it like that. L is 81 to the 1/4, so that's gonna be a 3 times 3/4, and then k to the negative 1/4, again, that simply means this 625 to the negative 1/4, so that's gonna be 1/5. So plug that all in, and you're gonna get 135 apparently. Okay, all right. Okay, so we have the values. What do they mean? Well, it's going to mean that what? When 81 units of labor and 625 units of capital have been produced and sold. No, sorry, thinking of the last problem. Have been used or have been invested, right, in this company, the production, that's a company's production function. So P stands in for production. So how many units you're producing. So the production is increasing by how much? 347, I'll round down, units for every extra what? Unit of labor. So if you're going to plug in or invest one more unit of labor, so 82 instead of 81, the production's going to go up by 347 units and is increasing by 135 units for every unit of capital invested. So if you're going to put in one more unit of capital, so instead of 625, you're going to put 626. That's going to increase your production by another 135 units. So that's what that means. All right. Okay. So there's that. Okay. Let's see. I'm going to last problem. Here's about a car dealership. So a car dealership sales depend on the price of the car, sure enough, and the amount spent on advertising. So you got to get the people in, and then you have to find the right price for that car. Good. Okay. If the sales in thousands of dollars are, here's a function, that better be a P, and this better be an A. Find and interpret the marginals SP and SA. So SP, first of all, is easily going to be what? The 20 goes away. The derivative of this is just a negative 0.5, and that's it. Yes, there's no other P in there. Now, the derivative with respect to A, there's no A here, there's no A here, but the derivative of this is a 0.6A. Okay, what do they mean? That means that what? The sales, right? The amount of sales in thousands of dollars will decrease by how much? Will decrease, so I already used the negative, right, from it. Will decrease by what? $0.5 thousand for every what? The amount spent in advert, the sales in thousands of dollars, if for every what, the price, right? So for every, I don't know if it's a $1 increase, but I'm just going to say 1,000. I didn't quite say, but I'm going to keep it in thousands. 1,000 dollars increase in price. Okay, so if you're gonna go up in price by $1 more, it's a change in price. So if you change the price by 1, again, remember this is a slope, right? So what does the slope tell you? It's the change in the sales with respect to the change in the price, right? So if this is 1, this is going to be negative 0.5. So the sales go down by 0.5 for every 1 increase by 1 in the price, and they're going to be in thousands of dollars. Okay. The sales, depending on A, will mean what? That the sales will increase by how much? By 0.6 times A. So this one is fixed, right? There is no p-value in there. So it's always going to be that. It's a constant. There's no p left in here. But here, obviously, it's going to depend on the value that we're plugging in for A. So this is a constant increase. It's just a line, basically, right? One that goes down. This one's changing, right, depending on the A. So whatever value we would have plugged in, this will be 0.6 times that value, right? That's what we got. It will increase by 0.6 times A for every what? $1,000, well, thousands. For every extra $1,000 increase in ads. And that makes sense. Okay, you're going to spend more on ads, you're going to sell more cars. You're going to increase, I'm filming through a grid, so that's why. You're going to increase the price of the cars, the sales are going to go down, right? So it totally makes sense. So one more time, what that simply means here is the change in sales with respect to the change in advertisement amounts. So for if you put 1 more in ads, you're going to get 0.6 times 1 more into wherever that A meant, into the sales, right? So if you increase the ads from 5,000 to 6,000, then the amount of sales will be 0.6 times that 5, right? That 5,000. So you go from 5 to 6, that still is a 0.6 times 5, right? Because it depends where you've started, right? So it depends on A. Okay. All right. So this is it. That's section 4.2.